Hello, Daniel Rioux. Thank you for coming to our series of mining interviews, for
Thank you.
participating. Today we're going to talk about density measurement and control in the thickening process. First of all, it would be nice if you can give a little introduction about yourself.
Sure, my name is Dan, and I'm an instrumentation technologist in a nickel mining company in Canada. And I'm very lucky to have worked with some very talented people in both the pulp and paper and the mining industries on some really challenging controls. So today I'm going to talk about some of my experiences with installing and controlling density gauges, and we're going to use thickener underflow as an example.
Okay, great. So what would be the first step for implementing the density measurement and control?
Well, the first step is the actual installation, and that's pretty much the most important one.
Does the orientation of the pipe also matter?
So this is where it gets, like, the positioning of that density meter becomes that much more critical. So typically we would want to use a vertical installation because, again, settling in a vertical pipe is not really possible, right? Unless it's a really, really bad design, completely oversized, you could have surging density, basically stuff slowing down and then raining, if you want to picture that in your mind. The heavy material would start to settle out and crash within a vertical section of pipe. But that requires a lot of like gross oversizing of the pipe, but it does happen. But basically a vertical orientation is best because the solution will not have anywhere to settle. So that is your best approach.
So you always make sure that settling cannot happen, so your instrument is fine in that location. Right. Yeah.
So you would then be mounting the meter as close to the pump discharge as possible, typically within about 1 or 2 meters. You can't go too close. And but now you're going to be on a horizontal line. So, yeah. And you're going to want that dilution valve as close to the inlet of the pump as well. So now positioning of that meter becomes key because you are definitely going to be facing high risk of settling interference with the meter's readings. And that piping should also you should also do the engineering behind it and make sure that that piping is just the right size you need, because some people think that a bigger is better, but it is not, right? Yeah. So if it's too big, the dynamic effects drop out. Yeah. So your pipe has to be the minimum size it can possibly be so that you maximize your pipe velocity so that you won't have settling, because all slurries have different critical settling velocities where basically material will start settling out, and as you start losing pipe diameter, the velocity is going up, so you end up hitting a balance point. Where that balance point is and how much of the pipe is obstructed, it's a result of how well you've engineered your piping.
That's about having good assessment of the plant design and what you need and how much you process, and
absolutely,
So when you have this meter afterwards the pump, very close to the pump, and you have the dilution point in front of the pump, also very close, then you can quickly see the changes and the results of the changes. So
correct, I mean, you have maybe, if you have 3 meters of distance, you're talking about maybe 5 seconds. It's not too big of a deal, right? The controls can typically handle that no problem. It's big delays that will cause you some real headaches.
And if you have it right behind the pump, there's probably also a bit more turbulence because the pump is creating some turbulence in the pipe, or
it depends, right? See, like a positive displacement pump does not create a whole lot of turbulence. No, it just sends a pulse, and then basically here's your volume and it's coming down the line, right? So it's not like a centrifugal pump, right?
No, okay. So it depends on the type of pump you use.
Absolutely,